So in our final examination of this tool, I've created a set of nodes that allow us to create panels. And in this case, when the panel value or the image that we're scanning and representing, when the brightness value goes to 0, it actually substitutes a panel. It substitutes glass for that. And that allows us to create this actually multi-material surface. And we still have the idea of panels having different depths, although I don't think that's really nicely articulated in here right now, but you can see there's a few different depths of the panels. And when they go to 0, the panels actually become a substituted material and become glass. So let's take a look at how we accomplish that in a dynamo definition. So in this case, this is still building on we're still in the same document we've been working on. And in order to kind of deactivate this whole function up here, I haven't put in logic switches, but what I've done is I've just disconnected things. I've taken the browser path and no longer connected it to the function, and I've taken the surface array slider and pulled it down to 0. That way there's no, at least in my head, there's no computational activity happening over on this end of things. So it's really basically kind of deactivated. And then over here, what we've done is we've just taken almost the same elements and copied them over. Except in this case, so we have the same kind of image processing, but we have the idea of now this, instead of being an array of dots, it's going to become an array of panels. So one of the key elements here is to make those panels rectangular. So instead of having it step in a range that's uniform in both directions, I've added a second range that allows us to step both 4 units horizontally and 1 unit vertically. So I'm feeding in X and Z's according to that and generating this coordinate system. And I'll go ahead and highlight that right now so we can see what that coordinate system looks like in the background. So now you can see the dots are, and let me just see if I'll just zoom in here so you can see. So what's actually being highlighted too is now we're working with the idea of a coordinate system so we're seeing the X, Y, and Z coordinates laid out at the same time. So the idea is points by coordinate. We have all the points, but we actually need this kind of coordinate system as a requirement for how we're going to create the rectangles next. Actually, let me step back. I'll just unpreview the coordinate system, and I'll just show you the basic points that are underlying that. And there they are. So that was the first step. This is the basic step of getting us a 1x4 array. And then we add this coordinate system, because eventually, as I'll slide over here, we want to feed that into the idea of these panels that we make. So one of the requirements of these panels is that we have a coordinate system, not a point, but a coordinate system. So that's the function that allows us to define that point as the coordinate system. So at its primary level, what we're doing is we're feeding this coordinate system into our panels. I've made the panels just slightly smaller. So at the end of the function here, what we do is I'll turn on the rectangle by width. So there is our rectangles. They're actually in the Z plane, or I guess that would be the Z plane. They're flat into the Z plane. That doesn't make sense the way I'm saying that, but anyway, they're 3.9 units wide. That allows a gap between each one. And you'll notice that if we were to, let's just zoom in on these, the way it builds these panel systems, there's the rectangle, and right now we're controlling the depth of the rectangle with the image input. So where there's 0 values, there's no panels appearing. But the coordinate system is at the center of the panel. If we zoom way in here now, because that's 3.9, there's that gap between the panels. So that's our rectangles. We then make a surface out of those, so I'll go ahead and turn this off. And the reason why this has an error to it is because we're passing through 0 values, most likely. I'll go ahead and preview this. Now we've added solidity to it. Then over here we thicken it, and this is where we actually make the panel that we want to make out of it. And the height of that is 0.9. It's a 1 unit spacing on the grid, but by making it 0.9, that it creates this gap between the panel systems, so it's able to be visualized. So that's in the surface thickening function, and then that just gets output to Revit, and I give it the metal term, which is probably just basically white at this point, but that's the string name I've given for the material in the output to Revit. Now you'll notice that there's a duplicate thing over here for the glass panels. And the key element here is how do we, all these ones that are not showing, I'm going to go ahead and turn these off now so they don't pass through to Revit. I'll turn that preview off. And I got to go back and find where I left the points on. Points by coordinate, I have to turn that off again. Alright, so we have a clean slate. And now let's take a look at this idea of the panel logic. So what we're doing is we're feeding in the brightness, and I've got a watch box here. So this is actually happening just the feed right off the color brightness. And the other one is what happens if we pass it through a logic system. So this is this logic gate is kind of a little bit confusing. But anyway, we feed the brightness in, and true is 0, and false is 1. So in this case, what we end up getting out of the array now is anytime 0 appears, it assigns 1 to it. And anytime there's a positive value, something there to make it true, it assigns 0 to it, which is ideally what we want. So anytime there's a brightness of 0 coming from the brightness thing, we make the panel exist. And so, and anytime there's some thickness to the panel, we make it not exist. We take it down to 0. Now there's a whole lot of ways this filter logic could work, but this is just a quick and simple way to add a value that allows us to have it materialize. Anyway, so now what we have, so if you think about what's going on, we're feeding all of the array image into the solid panels. Whenever there's a 0, a panel doesn't get created because it can't have a 0 dimension. And that's really why it's erroring out. We could try to filter those out, but it's really unimportant in the function of this. I just would add a little bit of design overhead that I think would affect our clarity of what's going on here. Anyway, so we have the panels that show, we have the panels that we feed into an output, give it a material, and then we have another, we take that same whole system, that whole logic system, except this time we only give it panels that have 0 values according to the, and we give them 1s now because of the logic system we've applied to it. And then we feed it into the same system, same panel sizes, so this is actually completely identical, except that the output now is fed into a direct shape output that now has the string glass added to it. And so if we go now and look at what's going on here, if I preview this, we're going to get all the glass panels, and it's a little hard to see because they're all going to be gray in these previews. And if I turn on these, we get all of the solid panels. And when we bounce out to Revit, the effect is this. So I thought that was a kind of a fun thing to do, and obviously playing around with the images and the effects. Right now I have this linked to a, I think a Voronoi pattern. Let me see what we've got here for the image. Yeah, and so that's I don't know if I have it available to quickly show you on the desktop, but we've used that to create our meshes, so that pattern is relatively available to you, I think. But the effect that came off of it was rather clean. It would be nice for you to experiment with some other imagery there. So that's the whole overview of a system or a tool to do image processing and make some kind of wall components. And in the next video, I'll put together a few of the outputs onto some kind of a presentation sheet to give us an idea what we'd like to see for submittals.